Okay, so I'm going to so that's the end of the session today. Let's just spend a little time discussing this thing. For a course that you may have taught sometimes, please mention the course name and specify one learning outcomes related to understanding and one outcome related to skill. You may not have stated it in your course earlier, the course that you have given to students, but here we are asking for your course, whatever you teach, say I teach psychology or I teach math or partial differential equations or what have you, and mention one course outcome related to understanding. What should, at the end of the course, the student should understand. So you don't have to type at the end of the course, just put the rest of it and mention one learning outcome which is skill oriented, level 3, 4, 5. Okay, you can raise your hand and speak, or you can type it in. I will stop the share and we can discuss it also.
Sir, generally I teach a subject of web technology. So in that, one of the outcome that I have written is understanding the basic concept is related to basic concept, and skills is when the concept is applied and student do some practicals and perform some job, then we call as a skill outcome.
But please, let's look at this. Understand basic concepts. How will you assess it? You should say understand the relational database and normalization, for example. How will basic concepts? I mean, there may be a million basic concepts, right? And now when you say apply, what does that mean? Now you can
Yes,
state
yes.
it. The student will be able to design a database or something, or relational data, or will be able to design a web front end using these technologies and back end using these databases. Now that is skill based, which you can measure because you can give an assignment. Okay, so you can try to be more this thing about it, right? While it's okay to use it, will understand the basic concepts, that's, to my mind, that is, that can be put in every course. So every course we can put understand basic concepts, apply basic concepts. Then we don't need to worry about the course content at all. It is not tied to your course. Please tie it to your course. Okay?
Okay, sir.
Yeah, Pankaj, thanks. Well, thanks for the very informative session, Pankaj. So I had a question actually on the teaching and assessment. Can I ask that, or will you be taking that?
Yeah, please. So you can ask anything else you may want, things that you may have doubts or.
Yeah. So regarding the teaching and assessment, and this is something that I really face very frequently also, especially in the machine learning course. So one thing that you mentioned, that the student should be assessed only on what has been taught or discussed in that course, right? And I think that is only fair also. But many times what happens that, in order to solve a particular question, they need some basic knowledge. And in advanced course like machine learning or courses like that, there are students who are coming from multiple backgrounds, and some of them may have done the foundational courses, some of them they may not have even done the foundational courses, and which are not essentially many times captured in the prerequisite of the courses. So in that case, then how do you think this can be handled? If I am not sure,
you're saying that the students, you assume certain basic knowledge and you build your course on that.
Yes.
Right. Now, one way is, of course, there's different ways. I don't have a clear answer to these. These are all difficult questions. So you state, and generally we state, this is the knowledge assumed. If you don't have it, please go and acquire it, because that's not the scope of the course. But I can give you some hints as to where to go and read it. But that's the knowledge you're assumed to have. And I'm going to teach you this, which will help you develop these capabilities, these skills, knowledge, and I will assess you on that. The knowledge that you're supposed to learn in this that I'm teaching, which includes reading, assignments and everything that I give, I'm going to assess on that. Now you're talking about remedial background for students, so you have to sort of work out something in that thing. But for course design, you shouldn't worry on that. So that's operation. How do I help students who don't have the background to acquire the backgrounds, remedial sort of thing. Yeah, all of us have to do some of those things.
Yeah, perfect. Thanks. I think that clarifies.
Okay, some people have typed this thing, object-oriented, understand behavioral models and its components, apply concepts for designing a behavioral model for a use case. Okay, sounds okay. Multi-agent systems, understand multi-agent systems and their significance. I mean, that's okay. But since you're talking about multi-agent systems, this is almost like a recursive definition, right? You ought to have something analyze the different agent interaction techniques and their architectures. Okay, that sounds. If we to be able to analyze, that sounds good. Understand should not be used as an action verb. Okay, so someone pointed out that understand should not be used as an action verb. Yeah, that's okay. That's all right. It's better to use some more expressive words because understand it's hard to assess that the student has understood. So understanding is a level, but it is better to say whatever other things that he can explain, which you can measure far more easily. The student can explain how it works. So rather than saying the student understands how it works, you can say the student can explain the working of the motor. That's still understanding, but it's far more measurable. Understanding is hard to measure. So it's a good point which Chitra has stated. Object-oriented, let's say, what else? At the end of the course, the student will be able to outline the design alternatives. Excellent. Will be able to outline design alternatives and trade-offs in operating system design. Oh, that's wonderful. It just seems to me at OS level, this is now coming from a computer science background, probably very hard. But hey, look, if you can do it, it's a good outcome. It's a good outcome stated this thing. Okay. With single on this thing, the student will be able to write simple Python programs using basic data types, control structures, libraries, functions. Great. And you can divide it. This is very nice. You can divide it typically, for example, simple statements, control and so, and you can use different data structures that are available in Python, lists, sets, dictionaries, understands and can use them in writing programs. Very nice. Develop Python programs.
Good evening, sir.
Using libraries. Just let me just using libraries. Please specify Python has millions of libraries. So using some of the standard libraries or specify and files. Good. Yes, Mr. Divanshu.
Sir, I have just single question.
Yeah.
So this learning outcome we decide in the starting of the course.
Yes, yeah. Design of.
Yes, sir. But sir, sometimes it happens like depending upon our audience. Let's suppose I have designed a course and learning outcomes for the BCA students, right? But when we get into the touch of the student, we see a different background and those. So in that case, we have to change the LOs. We want to change, but it is already finalized. So how much percentage we can change the learning outcomes or?
See, there are two things you're mentioning. One is regulator in your university, how to change. Changing learning outcomes, hey, look, if for whatever reason you feel that these learning outcomes are too ambitious, you do the whole exercise again. Okay, too ambitious, let's remove some of the more difficult ones which require more time. And let's add some newer ones, easier ones of understanding, level of understanding. So that's easy. That's not, once you understand the framework, you can do that. But let me just say, I think in a college level, students don't change year to year dramatically. It's not that 1 year suddenly you have very, very weak students and next year, and so far you were having all students well prepared in math and everything, and suddenly you get a set of students who are not well prepared. It generally doesn't happen. So that's what I mentioned, that when you design the learning outcomes, they have to be proper. There's no formula to assess it. You have to assess, is this learning outcome satisfactory? Is it proper? Can the students learn it? I mean, just because I've said learning outcomes in the first physics course, I say students understand the theory of relativity. Hey, look, they can't. What's the point in putting something that they can't do it? Right? Or at the first math course, we say they will be able to solve partial differential equations or whatever, some very fancy math. You can't do it. Or in linear algebra, before they do, you say some very fancy matrix, this thing. So, what is the student coming, what knowledge the student is coming from? Your learning outcome has to be reasonable based on that knowledge and what you can teach in the semester box. You have only 3 lectures a week you can give some work to the student. So let's say the student can do about 5-6 hours a week outside the class. That's the only effort you have, plus the end 14 weeks. Only that much you can teach based on what the student knows from before. And that's related to what Gyanendra asked. So you have to make right assumptions about the student knowledge to build your learning outcomes. But hey, look, if sometimes you made a mistake, you change the learning outcomes. That is the problem. Yeah, especially I think first time when you design a course, one can make a mistake easily. You can be very ambitious. Let me teach this. I think I can cover all this. You realize you cannot, or you cover only so much, and then you realize that hey, look, you could have covered. Okay.
So while preparing the LOs, we should be very careful what we are going to do to cover those learning outcomes.
No, we haven't yet discussed about how to teach those, how to ensure, how to teach, we haven't yet discussed. We've just discussed establishing of learning outcomes.
Okay, sir. Okay. We'll wait for this.
Okay. We'll make a judgment whether these learning outcomes can be learned. Can be learned. Teaching we'll talk about. But
Okay.
let's not put, hey, at the end of the day, the student will know how to apply Heisenberg's uncertainty principle and Einstein's equations to do something. Hey, can't happen. Okay.
ठीक, sir. Thank you, sir.
All right. Course name, communication and storytelling. Produce persuasive presentations. Excellent. Understand audience, their needs and what you're trying to achieve with your big idea. Yeah.
Sir, you are muted, sir.
Okay, I got muted. Okay, course name. So you can say, so this was produce persuasive presentations following appropriate this thing. That sounds good. Understand audience and their needs. So I was saying instead of understand, you can say list out or list out the attributes of the audience and their needs or something like that. Because understand is a little hard word to sort of measure later on. Apply appropriate communication skills across settings. If you can convert it to, make a presentation, write a report or something, that could be compose a story that brings that's nice. Compose a story that brings together this. Very nice. Because if a subject is based on theory as well as implementation, we know how can we teach too many concepts like this thing. And yes, so you cannot teach too much as well as have them learn skill-based things. And that's where, again, that's what I keep coming to. Your learning outcomes have to be such that you can do it in the semester box of one course, not the whole. So you don't have the student all the time. You have only students' mind share for about 8-10 hours a week. So you cannot, and that's one of the main things. List of topics has this big problem. You just list the topics. I want students to know about this. You list them. And somebody say, hey, what happens about this topic? You add that also. And then, hey, look, you have to cover the topic. If there is less time left, you just in one lecture cover 5 topics. I've touched them, I've covered them, but student has learned nothing. So yes, when you're learning focused, you have to scope it properly. You have to put down what students' concepts can learn, not topics. Topics you don't learn. What concepts students will learn And you have to talk about what topics will go under that concept, and then what skills they will learn using those concepts, what skills they will build using those concepts. So it is a challenging exercise, and operating system is a good course because it's a good example. It's a huge course. Now, if you really have to teach everything you want to teach, it will take multiple years, multiple courses. So you have to scope it. And that's an exercise between the faculty, between the department. You know, it's everybody has to agree in an institution that yes, we'll teach this much. And what is this? We need to understand what are the skills and so on we do. Okay. Unsuccessful completion of these industrial drives. Okay. The student will be able to apply the theories of electrical machines, power, this thing. To implement, so the student will be able to implement electrical drive systems and analyze. Of course, he will apply the theory. So he can implement electrical drive systems and analyze transient behavior. These are two learning outcomes, and I think you should separate them. Very nice. He can implement, or rather implement electric drive systems, or build electric drive systems, I guess. Analyze transient behavior of electric drives. Great, very nice. Design BJT, MOSFET and IGBT gate device circuits, protection circuits. Yeah. And so I think circuits like BJT and so on. Cooling seems to me a different one. Cooling requirements for some, analyze the cooling requirement. But I'm not very familiar with this subject matter. But these are very nice, very nice. Computer understand the various memory systems and apply the techniques, and again apply. You have to sort of apply will to do something. So let's just say building a small computer system. The student at the end of the day can build a small computer system. Great, probably very challenging. We don't have to say apply the techniques. Of course, to build, he will have to apply the technique. So what skill? He can build the computer system, right? Okay, for operating system, for example, earlier, long time back when I was a student, there used to be a learning outcome in some courses that the students in groups will be able to design and implement and build a small, tiny operating system. We used to do that. These days it's very different.